Hello. Today we are going to have a look at how 3D models and 3D point clouds can be used to create insights into estuaries in terms of the sediment erosion and deposition when it comes to flooding, and how this can help us with management decision making. So what's really great about the latest updates in WebODM and also in the Cloud Compare world is that we can align our data sets really quickly. We can actually align these data sets in processing rather than in post-processing. So if we have a look at this very nice baseline data set of the river system, we can see that there's quite a lot of sediment deposition, and there's some changes here in the river mouth itself where excavation has occurred to provide a channel for water to flow out once the river itself reaches capacity to prevent flooding in the surrounding areas. What's nice about being able to align your data in processing rather than in post-processing by having to pick points, for example, is the accuracy that you get. It also saves a huge amount of time. So if we look at our baseline data set, and then we look at our follow-up data set, which was aligned in processing, we can see that there is very little change between the points on the fixed structures, such as these two bridges here. So what that allows us to do is make very quick change models, such as this one, which we can enhance finer details out of using a different color ramp. So this is our custom color ramp, so we can clearly see where material has been removed from the ecosystem and where it's been added. And we can tell how many meters by using the scale bar here on the right hand side. Everything else like fixed infrastructure here, such as the roads or the landscape surrounding the estuary, will remain stagnant in these colors. So here we can see sediment deposition, and here we can see erosion. This therefore allows us to quite accurately compute the change in volumes of sediment deposition and erosion within this ecosystem by isolating a certain area and then computing the 2.5D volume between the two different point clouds. Our baseline data here and our comparative data here. So we can see that we have 99.7% of our cells within this study area are correctly aligned. And therefore we have our added volume, so deposition, and our removed volume, which is erosion. And the volume calculation here is the difference between the two dates, that plus that. That's the remainder there, and the surface area is 4.8 hectares. So how is this useful? Well, we can have a look at the profile of the river system and find its lowest point. That is represented here by this dot, which is also represented in the 2 dimensions by the dot above. By knowing the lowest point of the river, we can therefore determine where we need to dig the slit trenches. So when the river does start to flood, the water will break through at the optimal point, preventing flooding to the surrounding infrastructure and recreational areas. This will help prevent incidences like this, where the trench was dug in the wrong position and therefore didn't allow the water to escape the river system correctly. To learn how to align point clouds in processing and fine-tune the alignment in post-processing and generate change detection models and also calculate volumes like you've seen here, please go to GeoWing Academy today.